In this video, we'll be looking at the area of a parallelogram. We're going to take advantage of the fact that in previous videos, we already established the area formula of a rectangle and the area formula of a triangle. So if we can view our parallelogram in terms of rectangles and triangles, then we can use those area formulas to come up with the area formula for the parallelogram. Let's take a look at how to do this. Here I'm going to take my parallelogram and cut off a triangle, move and reattach it to form a rectangle. Then I'll take the same parallelogram and I'll cut it along the diagonal, and you can see that I form two triangles. I have the parallelogram in terms of triangles. I'll do this again for this slightly unusual parallelogram. It's really long and skinny. It would be hard to snip a triangle off the end to make a rectangle, so I'll just look at my two separate triangles here, knowing that I can find the area of each triangle. So now let's try to figure out the area formula. So here I've drawn up my first parallelogram where I used moving and additivity to form the rectangle. Well, the rectangle is length times width, but in this case I'm going to go with my base times height formulation here, like I did with the triangle. So the area of the parallelogram in this case is the same as the area of my newly formed rectangle. So this is just going to be my base times my height. Let's confirm that with our triangle method. So here I have my two triangles, and I know that the area of my parallelogram is going to be the area of my green triangle plus the area of my blue triangle. Looking first at the green triangle, I have my base B, and I'll draw in my height, H. When I go to do the blue triangle, notice that here my base was 1, 2, 3, 4, 5, 6 units long. On a parallelogram, opposite sides have the same length, 1, 2, 3, 4, 5, 6. So I'm just going to give this the same label as B and know that these are the same length. Same with the height. My height here, 1, 2, 3, 4, 1, 2, 3, 4. They both have the same height. So let's go ahead and fill in this information. Well, half of a base times height plus half of the same base times height gives me one whole base times height. The half plus the half gives me one whole base times height. So we got the same area formula. This makes sense here. Down here with our skinny parallelogram, we have to be a little bit more careful about our base and our height. So we already know that these triangles have the same area. We saw that in the previous example. And let's look at what the height will be. So we'll have our base here, or we could have called our base up here. And then our height, we're going to draw a perpendicular segment that's an extension of the base here. So our height is from here to here, 4 units tall. We'll label it over on the side. Similarly, with our green triangle, we had our base. We come up to the third vertex, drop that line that'll be perpendicular to an extension of the base. It still is the same length of 4 units right here. So we'll just label over here our height, our base, and again, we can think about this as the area of the blue triangle plus the area of the green triangle, which will give us base times height. This triangle method works nicely for any parallelogram that you have. Let's look at another problem where it's easy to make a mistake. Here we want to find the perimeter and the area of the parallelogram. The perimeter is the distance around. It's a 1D measurement, so I can add up the length of each of my sides here. So I will have 3 plus 5 plus another 3 plus another 5. In this case, I had 2 of my 5-unit sides and 2 of my 3-unit sides. Here, it's easy to make a mistake with the area of the parallelogram. It's really tempting to think, oh, I have adjacent sides. Let me just multiply 3 times 5 right here and see if I get my area. But 5 isn't our height because our height has to be a perpendicular line segment to the base. So our base and our height here, 3 times 4, give us an area of 12. Let's confirm this. Notice that the triangle that I drew there actually corresponds. If I were to cut off this triangle and relocate it over here, there's 3 units on the side. So here's our 3 units on the side, and it has 4 vertical units, 4 vertical units. So we end up with this rectangle, and we can literally just count the square units inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our area is 12 square units, and we need to be careful not to have it 3 times 5 or 15 square units because that does not correspond.